Okay, welcome to 5.1 day 1. We're going to break up 5.1 into 3 different videos and days and kind of chunk it to hopefully make it easier on you guys. All right, your objectives here are I know the fundamental identities, the reciprocal quotient, Pythagorean. It's not supposed to say that, it's supposed to say cofunction. I will fix it on yours, and even odd. And then actually in class, we're going to tackle the next objective. I will be able to use the fundamental identities to simplify trigonometric expressions. So in this video, you're just going to find out what they are. We're not going to do any simplifying yet. We'll do that in class. Okay, so the reciprocal identities, these should hopefully be familiar to you. Cosecant goes with sine, right? They're just reciprocals of each other. Secant goes with cosine, reciprocals of each other, and cotangent goes with tangent. They're just reciprocals of each other. All right, so I put this unit circle on here because I want to talk about something that I know you guys know, but let's just go over it again. So if we have the unit circle and the radius is 1, and we have the point x, y, then this is x, and this is y. Okay, so therefore, the sine of theta, let's put a theta in here, the sine of theta, which is opposite over hypotenuse, would just be y over 1. So sine theta is just the same as y. Cosine theta is adjacent over hypotenuse, so x over 1. So cosine is x. Therefore, tangent is opposite over adjacent, so y over x. Okay. And I'm telling you this, or reminding you of this, because that's what is going to bring us to our next identities. And as I go through these identities, I'm going to show you where they come from, because I think it makes it easier to remember them that way. All right, so since we know tangent is y over x, and since we know that sine is y and x is cosine, we can just replace them and we get these identities. Then because cotangent is just the reciprocal of tangent, as we just saw above, then cotangent would just be cosine over sine. Okay, so what about the Pythagorean identity? Well, let's go back to this triangle here. Right, so if I wanted to solve this using the Pythagorean theorem or plug this into the Pythagorean theorem, it would be x squared plus y squared equals 1. So if I take x squared plus y squared equals 1, and then I substitute out, well, x is the same as cosine, y is the same as sine, equals 1. So there we go. There's one of our Pythagorean identities. We're actually going to end up with 3 in the end. So we're going to do a few little things to this one to come up with some new ones. Okay, so let's take this original one and we're going to divide through, so cosine squared theta plus sine squared theta equals 1. I'm going to divide each part by the same thing, so I'm not actually changing anything. But I'm going to divide everything by cosine squared. So cosine squared theta and cosine squared theta. All right, so these would just simplify to 1. Sine squared theta over cosine, that is cosine, it's hard to read, squared theta. We covered above, sine over cosine is tangent, so this is going to give us tangent squared theta. And then lastly, 1 over cosine squared theta, well, that's just the reciprocal of secant squared theta. Okay, so this is the other one, so we're going to end up with 3 here. So here's the first one I gave you. Here is the second Pythagorean identity. And then let's come up with another one here. So this time over here we divided through by cosine. Over here I'm going to go ahead and divide through by sine. Okay, so go ahead and get this down, but we're just dividing through by sine. So cosine divided by sine is going to give us cotangent squared theta. Then sine squared divided by sine squared is just 1 equals, Well, this is the reciprocal of cosecant, so cosecant squared theta. And there's our third one. Okay, and to help you memorize these, I'm stealing a little memory trick from Miss Schofield. She likes to say I plus tangent squared equals secant squared. To help you remember that, I tan in a second. The 1 is I, tan squared is tan, and secant second. So how about this one? Slept in a cot in Colorado Springs, Colorado, because right here you can actually switch the 1 and the cotangent. So I, 1, slept in a cot in Colorado Springs, Colorado. So a couple cheesy ways to hopefully help you remember these Pythagorean identities. This one hopefully you can come up with pretty quickly in your head just by remembering the Pythagorean theorem. All right, let's flip over to the back here. Okay, cofunction identities, aka complementary angles. So let's look at this. So if I have this triangle here, and this is going to be a right triangle, and we're going to call this side A, and this side B, and this side C. Okay, and then I'm going to call this angle theta. Okay, now think about, in a triangle, we have 180 degrees. And if I subtract 90 degrees, well, I'm left with 90 degrees. All right, so these two angles together have to equal 90. I'm subtracting out this angle, and I'm left with 90 for these two. So to do this in radians, this would be pi over 2. So this angle, if this angle is pi, and both of these together pi over 2, well, we're going to call this angle pi over 2 minus theta. I just redrew it. I don't know if that was much better. All right, so that means that we're going to refer to this angle as pi over 2 minus theta. So if you look at each of these, we're trying to find out what sine is of pi over 2 minus theta, right? So this right here. What is that sine? Well, let's use this. So sine would be opposite over hypotenuse. So we have b over c, and I'm actually going to write it down here. b over c. Well, b over c is the same as the cosine of theta. So b over c, well, if I were to find the cosine of theta, it would also actually put the equals sign over on this side. Right, so sine was b over c equals cosine theta. So when I'm given this, I can substitute in cosine theta because they're the same thing. All right, cosine of this angle here, well, cosine of this angle here is adjacent over hypotenuse, so a over c. And a over c also happens to be the sine of theta, the sine of this angle. So the sine of this angle would be opposite over hypotenuse, so sine theta. Okay, so tangent of this angle would be opposite over adjacent, so we get b over a, and b over a would be the same as, well, if I'm looking from theta, adjacent over opposite is cotangent. So you can see that there's a pattern here that I've set it up so that your sine goes with your cosine, your tangent goes with your cotangent. So you can go ahead and do this, or you can take my word for it that this is going to be tangent theta. Okay, secant. Well, secant is going to be hypotenuse over adjacent, so c over a, which is going to be the same from theta, the cosecant. The cosecant from theta, which is hypotenuse over opposite. Whew, I am really tired. I'm struggling here. Sorry, my brain isn't working that quickly. All right, so that means that cosecant of this angle is going to give you, of course, secant of theta. Okay, last one I'm going to show you here, odd and even identities. And you're going to have to think way back to when we learned about odd and even functions. So an even function is symmetrical over the y-axis. So if you remember, x squared is an even function, right, like that. And then we talked about what that would look like algebraically. And what that looks like algebraically is if you were to apply a negative to every x, then out would come a positive. And then an odd function is symmetrical or over the origin. So that looked like this one. So x cubed. So it's flipped over the y and then over the x-axis. And this one algebraically, well, if you were to make all the x's negative, then it would come out negative. Right, so let's bring that together and how that works with these. So what kind of, and let me make it so we can see both of these. All right, so what kind of function is this? That's the first question we have to ask ourselves. This is an odd function. All right, odd. So that means that when I have a negative angle in the sine function, it's going to come out with a negative answer, or in this case, since we're not actually using numbers, this is how we're going to write it. And we're going to use this to replace, we're going to use this to replace this in some functions. And then cosecant, well, we're still talking about odd here. If you recall, this looks like kind of like this is what our cosecant one looks like. There we go. So still an odd function, flip. Okay, so this will also come out negative. And let's talk about what this looks like in a unit circle, because I think that's going to help you pull this together. So if I have the unit circle, and let's just pick an angle, any angle. Let's find the sine of pi over 4. That's an easy one. So the sine of pi over 4, well, let's go ahead and draw that. This is pi over 4. So sine, we'd have 1, 1, and then square root 2 here. So opposite over hypotenuse would be 1 over root 2. Okay. However, if we then made the angle negative, so instead we did sine of negative pi over 4, well, what will we get then? So here's negative pi over 4 down here. Can't fit it all in there. So negative pi over 4. So now we have a negative 1 here and a square root 2. So opposite over hypotenuse would give us negative 1 over square root 2. So you can see that when this is negative inside, when you make the angle negative, the answer then becomes negative. Okay, so what about this function? Well, this function is even. It's flipped over the y-axis here. So when we make the angle negative, out's going to come a positive. Same with secant. And if you remember, secant looks like this. Right, so still even, still flipped over the y-axis. So same deal here, out's going to come a positive. And let's go back down here just to prove it to you. So this time we're going to take cosine, and I'm not going to use a different angle, so I'll just use the same triangles over here. So cosine of pi over 4. Well, cosine's adjacent over hypotenuse, so 1 over root 2. But then cosine of negative pi over 4, well, now we're in this triangle on the bottom, and it's still adjacent over hypotenuse. Well, that 1 is still positive. So even though this became negative, even though these angles are negative, this is still positive. Okay, last one here. I'm not going to show you with it on the unit circle. We're just going to look simply at the graph and determine even or odd. Well, this one is odd, which means the negative comes out front here. And here the negative comes out front here. All right, that's it. I just wanted to show you the background on all of them to help them stick in your head. It may not make a whole lot of sense right now what we're going to do with them, but it will make more sense in class. So I'll see you there.